Yes, you've heard already a couple of times today that science has a role, an important role to play if we are to achieve a sustainable management of our seas. And what I like to do, to use my presentation for, is to take a couple of examples which I hope will illustrate why this is important, why it is important that we have knowledge of the ecosystems in the Baltic Sea. So the ecosystems, the plants, the animals below the surface of the Baltic Sea. And also that we use this knowledge in our management. And in my presentation, I will have a focus on coastal areas. And I will take my examples from Baltic Sea coastal ecosystems. And one reason for that is that I'm myself working a lot with coastal ecosystems. But also, another reason, important reason, is that the Baltic Sea coastal areas are hotspots for biodiversity, but they are also areas where we use the sea for many different purposes, and many different actors are involved there. So there are a lot of potential conflicts also in coastal zones. And finally, but not least, I think that this is maybe the area where the municipalities has the strongest mandate to actually be involved in management. So, as I said, I'm going to talk about the ecosystems below the surface of the Baltic Sea. So the plants and animals that we normally see quite little of when we are out at the coast. This picture is taken on a very calm day, which means that we can actually start to see a little bit below the surface. You can see here the algae that's growing on a cliff. Quite typical environment for outer parts of this picture is from outer part of Stockholm archipelago. If you go to more sheltered areas in the inner parts of archipelagos or to the lagoons in eastern or southern Baltic Sea, you can find this type of vegetation. This is rooted plants that form meadows or forests in more sheltered areas. So these algae and these rooted plants, they form the vegetation in coastal areas, meadows or forests in the Baltic Sea. And they perform a number of important functions. For instance, they produce a lot of plant material that is food for the herbivores, the plant eaters in the sea. We don't have any really big plant eaters like we have on land. The plant eaters in the Baltic Sea are really small. They are eaten in turn by small fish, sticklebacks for instance, and the small fish are eaten by larger fish, the fish-eating fish or the predatory fish. And in coastal areas of the Baltic Sea, the perch is the most common species, but you will also find a lot of other species, like pike, for instance, another well-known species. And then the large fish are eaten by seabirds, seals, but also by us. They're good, nice food also for us humans. So you can see the vegetation has an important role as the basis for this food chain in the Baltic Sea, in coastal areas. But these forests of the sea, they also have a number of other functions. Just as the forests on land, they are able to transform the environment where they grow. You know from forests on land that we know that they can take up and bind a lot of carbon, for instance, and help mitigating the effects of all the carbon dioxide that we release from burning fossil fuels. And what recent research has shown is actually that also coastal vegetation, this type of rooted plants, they can store a lot of carbon. There was a recent study from Denmark where it's shown that seagrass meadows in Denmark can, in some areas, store more carbon than forests on land. But the plants also take up nutrients from the water, and with their roots they bind the sediment, which means that less particles are whirled up in the water from the bottom, which means that they also contribute to a clear water. So the water is less turbid, clearer, if there are plants than if there are not plants in an area. So we see that the vegetation has a number of important functions, but sometimes coastal vegetation becomes a nuisance to us. I guess that many of you have experienced sometimes a lot of algae drifting ashore in masses on beaches, piling up, rotting there, and smelling awfully, and really interfering with our use of the seaside. So why is this? Why is the vegetation suddenly becoming a problem then? Well, what we know is that these algae that are washed ashore like this, to a large extent, they are filamentous, fast-growing algae that are favored by the high nutrient concentrations in the Baltic Sea, resulting from the release of nutrients to the sea. Because what happens when you go from a situation with low nutrient concentrations in the water to a eutrophic situation is that you get a change in the vegetation. So to your left there, you have a nutrient-poor situation typically with seagrasses, clear water, and the more you go to the right, the more nutrients you have, you will see these fast-growing algae growing on the seabed, on the bottom, but also on top of the rooted plants, shading them, suffocating them. So finally, you get a situation where you lose these rooted plants. You only have the filamentous or the fast-growing algae. And what you can see, then you also get more turbid water because you lose this function that the rooted plants have to bind the sediments. So we can see these signs on land with all these algae being washed ashore, but you can also see these changes below the water, that you get algae growing on top of the rooted plants and affecting the system and the functions of the system. So we know that the release of nutrients contribute to these changes in vegetation. But what science is also more and more showing is that the fish also has a role to play in this, and I'm going to explain how that is. So what is seen in several coastal areas, not everywhere, but in several coastal areas of the Baltic Sea, is there's been a decline in large predatory fish. For instance, perch that I was talking about, and pike. And one thing that happens then is that when a large fish decline, you get many small fish in the system. And because these small fish, they are eating small animals, there will be less small herbivores, more mesograzers. And these are the ones that eat the algae. So you can actually get a situation with a lot of algae when you get less large predatory fish in the system. Contrasting then with a system where you have a large predatory fish and you can have healthy vegetation without a lot of algae. And interestingly, science also shows that the vegetation is really important for a lot of these fish species, for instance, pike and perch, because that's a nursery area. That's where the fish lay their eggs and where the young fish spend the first part of their lives. So back to this overviewing picture. What I try to show with this example is how interlinked the species and the habitats are in coastal areas. So you have habitats that are important for a lot of species. You have species that are important to control or to buffer the effects of nutrient, for instance, on the habitats. And one consequence of this is that if you do something somewhere here to change the system, you can have a lot of indirect and unexpected effects on other parts of the ecosystem. So for instance, if you release nutrients, changing the vegetation, you may change the opportunity to fish in the system. I was talking before about that perch is a popular fish species to fish, or historically it's been economically important. Now it's a popular fish for recreation. But if we fish a lot, that can actually also affect vegetation and the water clarity, affecting other recreational uses of the sea. And if we want to have a lot of predatory fish in the system, maybe we have to do something about the large predators, the seals and the seabirds, the cormorants. But those are also part of the. I mean, that's a real controversial thing because they are seen as very valuable and important for recreation, nature tourism as well. So what I try to show with this is that if we don't know how these linkages are in the ecosystem, there will be a lot of hidden conflicts that we cannot account for in management. So then, what is the solution to this? Well, the advice from science, and that's also now occurring in the legislation, the EU legislation around, connected to management of coastal and marine areas. It's that we need to move towards more integrated management of coastal ecosystems. Another word for that is ecosystem-based management. And I would like to highlight two important components or principles in ecosystem-based management that I think are really relevant for the discussion here today. And one is that ecosystem-based management should be based on knowledge of the ecosystem. And that's really what I've tried to show here, why that is. Because if we don't know of the linkages in the ecosystem, we will not be able to manage these hidden links or hidden conflicts. And that's why I'm here, and I'm happy to be able to tell you about this. And I will also be here after the presentation, if you have questions, and also after the conference. And after me, you will hear other scientists also talking about the knowledge that can be used for ecosystem-based management. But equally important is how we set the management targets that trade off between all these different interests. Because that's also really important component of ecosystem-based management, how these management targets should be set in collaboration between all the potential interest groups in an area. And this is, of course, a really hard nut to crack. How should we do this? How should we get this going? How should we get these discussions and these trade-off balanced? And I think that here is somewhere where I think municipalities can really take on a role. And one process that potentially can be important for this is marine and coastal zone spatial planning. We are used to planning our land areas in order to manage conflicts and balance between interests. And now we are also supposed to start planning our marine areas. And this is definitely in the mandate of municipalities to plan their coastal areas. And as Marco will show in the presentation after me, there are now more and more science and more maps, knowledge about the underwater ecosystem that can be used to do this in a good way. Do I still have some time, or should I? 1 minute. I'll skip this. I thought I should give some more specific advice around the habitats I've been talking about, but instead of doing that, I'll just tell you that on the 13th of March, there will be a conference at Stockholm University where we're going to talk more specific. This talk now is more a very short summary of what's going to be discussed in that conference. So you're really welcome if you are more interested in how to manage coastal areas. And with that, I finish, and thank you for your attention.